Hello, good afternoon, everybody. This is Nirmala from Econ4000 econometrics class. So I'll be solving the question number 4, which was the Excel problem, which everybody got stuck last week's session. I figured out how to complete the problem, and let's get started. So this is the file I created for this video. We're going to work on this particular file, Contagia assignment. So let's go to our problem. Let's just start from the beginning. This is the course page that we have from our MyEcon class. And as you can see, we have a check mark on question 4. That means I already did it. So let me click over here. It'll show us the answers with the numbers that I dealt with. So your numbers will be quite different. So I'll be showing you the methodology of completing this particular task. So first of all, you have to download the data from this particular question. So what my Econ Lab does is it keeps all the data in this particular tab. So if you click this tab, one prompt is going to show up, and if you copy it to your Excel sheet, it's going to be pasted onto the particular Excel sheet very, very perfectly. So if I just click it over here, it gives me a prompt as per instruction. The table has been copied and is ready to be pasted into Excel. Press OK, minimize this, and if I go to our particular file, and the main sheet, this is the sheet that I'm going to walk through for the entire video. Let's zoom it a little bit. I paste this, and voila. All the data from that particular question is pasted into this sheet. So let me just give you a brief piece of a hint over here. This is the formula sheet that I've particularly created for this problem, because we will be needing all these formulas so that you just don't get lost. And this is the sheet that I'm going to work through the entire problem. So let me just arrange the data a little bit so that it looks pretty good. Merge this and this, and give it a yellow color. Color, the borderline. This is the borderline. Just zoom in a little bit so that it's easy for you guys. Put this in the middle. Just let you know, guys, this is a Mac OS platform, so the Excel version that I'm using, that's basically compatible to Mac OS. So the Windows version of the Excel will be a little bit different than this one. So I suggest you to play around a little bit. You'll be fine. So the first problem, the first question was of the question 4 is compute the marginal distribution of age. So from what do we know from our last discussion? We know all these values in the table that we see are the joint probabilities of two of the variables. In this particular question, one variable is called the age, another variable is the hourly earnings. So all these joint probabilities are provided over here. And marginal probability is the summation of all the joint probabilities in a particular column. So this is pretty easy. If we put a marginal, header, this is going to be all the values from this particular row of this particular column to this particular row of the same column, and that's going to be the marginal probability of age 25. See that it gets highlighted. So just close the parentheses, the marginal probability of age 25. We drag it over here. Spin all the marginal probabilities of different age groups, 25, 26, up to 33, 34, which is this particular value. Let's just take out the error. And since this is a result of question number A, put it. Let me just double line it. So it'll be easier for us to figure out. All right. Perfect. So this is the marginal probability of all the age group that we are seeing over here. But before continuing the next step, let's just do it orderly fashion. Let's calculate the marginal probability of all the hourly earnings as well, because we might need it in the future. And it's actually very easy because you just sum it up all the columns and all the rows. Over here it'll be all the rows, open parentheses, click over here, Shift Command in Mac platform, Shift Control in Windows platform, and press the right arrow. Voila. And then close the parentheses. It will show up like this. I'll just repeat. Press Shift Command and the right button in the Mac platform, and Shift Control right button in the Windows platform. So now if I drag it up to here, it comes to all of these marginal probabilities of AHE. Just right over here. And this is H. Sorry. This is for AHE. So what we can do is we can do format cell to make it a 4 or 5 decimal places number. So it looks a little bit neat and clean. So we can put it in the middle. Alright. This looks pretty good. Okay. So now we are done with the first question, which was this, the marginal probability of age. The second question says compute the mean of average housing earnings, hourly earnings, for age 30. In my question, it's age 30. Your question might say age 31, 32, 34, whatever. So my question says for age 30, that is compute expected AHE given age is equal to 30. So now how did I do that? It's pretty weird. But let me just make it a little bit simple. Let me just go to the formula sheet, which is the first sheet over here. Just the first sheet over here. And let me just write it down a little bit. AHE given age is equal to 30. So this might look a little bit kinky. So expected. So if I consider average hourly earnings to be A and age 30 is equal to B, what is the conditional probability equation that comes to your mind? It's going to be probability A and B divided by probability of B, isn't it? So A and B is equivalent to A intersection B, same as A intersection B. It seems I don't have an intersection key over here, so I'm just putting it A and B. So probability of A and B from the table, what comes to your mind? Okay, let's see. if I say probability of A and B yes, so if it's A intersection B, and we have been told to age 30 with average hourly earnings. So what pops in your mind? You do a calculation over here that this variable multiply this particular probability, what will it give you? The intersection of hourly earnings and age. So if we do the calculation over here, so now let me show you a trick in Excel. This is pretty simple. So if you want to lock a particular column, just put a dollar sign before the column A. So there are column B, column C, column D. You want to lock a particular column or row, you just put a dollar sign before the column or the row. Over here, we are putting a dollar sign before the column, which is A. And I want the row G to be locked as well, so that I don't get any weird kind of values. Okay, so let's just do the chit chat, and all it pops up a lot of weird numbers. So now if we do a sum of this number, again this number, we get this particular number, which is a different color. Okay, so this is the first part of the intersection. So I got equal to this value. Okay, so this is the first part I got. Now just divide and the probability of B comes from age 30, isn't it? So age 30, the total marginal probability of age 30 was this value, right? So if we come over this formula sheet and press equal and go to our main sheet and press age 30's marginal probability, press enter. So both of our values are over here. So equal to this value divided by this value, 22.87789. That's the value is right over here. And that's the answer for question number 2. So we are done with question number 2, which was pretty easy till now. So let me just edit this over here. We can say this is probability of A and G and H. Right? Just it, format cells, number it to 6 decimal places. That's pretty good. Alright, perfect. So now, our third question is more easier than the second question. It says, below is a plot of our mean of average hourly earnings versus age. So it shows a positive growth in the x and the y axis, the mean of age, E and the age. Our average hourly earnings are age related. So as we can see, as the age increases, the mean of average hourly earnings also do increase. There are three options. The best option is yes, the mean of AHE and age appears to be positively related. So that means they're positively correlated as well. But that we will find out later on as well. But from this particular graph, we can easily understand that we are positively correlated because once one variable is increasing, the other variable is also increasing. The fourth question is they have given you all the variables, they have given you all the data sets. Use the law of iterated expectations to compute the mean of AHE, that is compute expected average hourly earnings. So from our discussions on Saturday, we have gone through the expected value, and these is the formula that I've written over here. That's expected x is summation of pi xi, pi xi. So probability of x multiplied by the variable x. So basically I've listed all the formulas over here just for the ease of work. So let's go to our main sheet. Let's just increase it a little bit. And let's make this column expected AHE. Okay. We'll maintain some consistency over here. And yeah. So when we are talking about expected AHE, we're talking about summation of pi xi. And since we are figuring out expected of average hourly earnings, the formula is equal to marginal probability, which is the summation of all the probabilities over here of one particular row of different age groups as well. So let's just do this. Marginal probability multiply five. So what I'm doing is over here is, look at the formula. It's summation of pi xi. So probability, whatever the probability is, say suppose for your understanding, probability is 0.23, multiply that the variable x is 1, plus probability of another variable is 0.21, multiply x2, plus probability of another variable is 0.14, multiply multiply variable 3. So this will give us the result of expected x, right? So don't get confused with this particular value or particular equation. I'm just making you understand with this particular example. This is pretty much a random example. I'll just delete this. Some people might get confused. Alright, so let's go to our main sheet. So this is exactly the same thing that I did over here. I've multiplied the marginal probability of of hourly earnings, which is 5, multiplied by the marginal probability of this particular average hourly earnings of different age groups, which I've calculated before. So if I press enter, this will give me this value. So I'll just do this. And so this gives me all the PI XIs of each hourly earnings. So for example, if I take this 0.88, it gives me the PI XI of 70 hourly earnings multiplied by the marginal probability of 70 hourly earnings. So that's 0.880278. So So now if I do a summation of all these, since the formula says summation, we're just going the flow from the formula. Alright, gives me 22.69. Here it is, 22.69144. Using exactly the same value as we have calculated over here. Alright, moving to the next one. Okay, consequently we have to calculate the variance of AHE as well. So let's just do a var AHE. Let's give it a box. And from the formula, what it says, let's go to the formula sheet. It says PI, summation of PI, x minus expected x whole square. So according to our discussion on Saturday, we have gone through different proofs and different mathematical models of calculating variance of a particular variable. So over here, since we have the marginal probability, we're going to just multiply our marginal probability with x minus expected x squared, and that's going to give us the value of variance. And over here, x is hourly earnings, average hourly earnings, I'm sorry. So just do it, very simple. It's equal to marginal probability equals x minus expected x whole square. So before doing that, I want to lock the columns. So this column is M, this is a column A, and that's a column N. Yes. So multiplication over here as well, and that is done. And this gives me the value of the entire rows. And if we do a sum over here of all the values, it's going to give me the variance. Okay, so there's some mistake over here. My value is 154.1023. It's not wrong. So now we have to find out what went wrong. Okie doke. Let's just look at the formula right now. $M4 A4 minus expected x. Oh, here is the problem. Here is the problem. This should be N34. There we go. M4 multiply A4 minus expected x, expected AHE over here, locking the columns. Actually, I want to lock the particular row as well over here. Making a square, and I believe it's going to be exactly. There we go. So the total value comes to 154.1023. That's 154.1023. That's the variance of AHE. Let's just do a double line. Okay, so we're almost done half of the problem. So now the most interesting part, covariance for both of those variables, AHE and H. Hello. So now what we're going to do is we're going to calculate the covariance of average hourly earnings and age. So what we learn in the covariance is you have to maintain a covariance matrix, what we have done in the class. So now if we look at the formula in our formula sheet, it says covariance xy. So if I consider age e as x and age as y, that's exy minus mu x multiplied by mu y. So I have the mu x, which is the marginal probability of this. I'm sorry, mu x is not the marginal probability, it's the expected AHE, which is 22.69144. So I don't have the expected of age till now. So let's just do that first for our convenience. Expected age is equal to, very easy, it's going to be PIXI, as according to the formula, this is our PI, and if we just, oh shoot, let's just, yeah, now that's good, now that's good. Let's just zoom out a little bit. Yeah, that's perfect. So PI multiply XI, okay? So I'm gonna lock the row over here instead of the column because I want Excel's file system to move from one particular column to the other. So that's why I'm going to lock the row, which is 3 in this case, and over here it's 34 in this case. So 34 is the row number, 3 is the row number, B is the column. So I want it to move from column B to column K, which is H34. So that's over here, drag it up to here. So that's give us up to H34. So just for ease, just calculate the var of age as well. That's going to be very easy. But before continuing, let's just do the accumulation. You can sort of sum 29.8432. That's my expected age over here as a total. So okay. The color. So variance would be very simple, equal to probability multiply, according to the formula it was probability multiply expected x minus expected x parentheses whole square. So now if I do this, x minus expected x parentheses whole square. So I want this to lock the row, where I want to lock both of them. I'm going to lock the row. And that's the variance. Let me just do the total That's my total variance. Just color over here. Color. Okay, lovely. So now I have got all the ingredients, most probably, yeah, got all the ingredients. Now, what I'm going to do is I'm going to make a covariance matrix. What is a covariance matrix, you might say? So now, let me show you something which we covered in class and in the group discussion as well. Equal to summation x0 y0 y0 multiply f x0 y0 plus x1 y0 multiply probability of x1 y0 bracket, and it goes so on. So if you can remember this particular formula, that for finding expected xy over here, what we're seeing over here, expected xy, we have to do a summation of all the relevant possibilities of variable x and variable y and the probability of those two variables and those two particular aspects of those two variables. So if you can remember this, let me just put it on Excel right now. It'll be easier for you. So for this, what I'm going to do is I'm going to make a new sheet over here, the third sheet. So I'm going to name it covariance matrix sheet. So let me just zoom it a little bit. I'm going to merge it. I'm going to name this covariance matrix okay. I think that's good. So now what I'm going to do is I'm going to go with the formula. So the formula was any two possible values of two variables multiply with their probabilities. So let's just go with the formula. So I'm going to work on this particular sheet for a covariance matrix, but I'm going to take all the relevant values from our main sheet, which is right over here. Alright, so let's do this. So equal to value of y 25, as we can see it over here in the top on the formula bar. We're going to work on this over here, okay? Multiply x multiply probability of these two particular variables, okay? So let me just do one thing before I continue to move on. So these are the locking aspect. What I'm doing, it's necessary for Excel, because Excel sometimes it gives us weird figures, weird values, because of unlocking and locking the cells, the boxes. So that's why we need to do the lock and unlock thingy that we are emphasizing in this particular problem, pretty much. So whenever we are considering B3, so I don't want B3 to move anywhere. So let me just lock it with dollar signs. So the dollar sign means you're locking the cells, you're locking the column, you're locking the row. So over here, I don't want B3 to move at all. So I'm locking the column B, and also I'm locking the row as well. So now 25 is not going to move anywhere. And 8,4 is 5. I want the Excel to move from 8,4 to A32. So what I'm going to do is I'm going to lock only the column, which is column A, but I want it to move from column 4, I'm sorry, row 4 to row 32. So I'll keep it as remains like that. For the other part, which is B4, right over here, as you can see, I want it to move from B4 to B32 as well. So what I'm going to do is I'm going to lock only the column B. That's it. And when you're done with this, just hit enter. And it's going to show up on your covariance matrix sheet the value over here. So now, how many values are over here? Let me just find it out right now for you guys. It's 29 values. Count 29. So there are 29 rows over here. So if I go over here and if I drag this, okay, so perfect. So it gives me 29 values as well. So now what I have to do to continue this covariance matrix is I have to go with the flow of the formula. That's this variable multiply this variable multiply the probabilities of these two variables. And we have to move on all the columns. Let's just do that. Just follow with me, guys. It's pretty easy. So equal to, go to main sheet, you click this, and multiply. You click this, and multiply, select this. Just put dollar signs over here since I don't want this to move. I want this to move only the rows, so I'm going to lock the column, and I'll lock the column over here as well. Hit it, and you just double click. That's it. That's what I'm going to do over here. 27 multiply 5, multiply this, put dollar signs, and put a dollar sign over here and a dollar sign over here as well. And I'm going to double click it, hit it. Alright, let's do it one more time. Actually, we're going to do a couple of more times. Alright, 28 multiply 5, multiply this. Dollar sign, move it up to here, dollar, and we're going to put another dollar, hit it. Double click. So we have done B, C, D, E, so we're going to do it next, F. Column F, multiply, 5, multiply, probability of these two variables, which is 29 age and 5 hourly earnings, and their probabilities. I'm sorry, there should be a dollar sign. And there's going to be our dollar sign, our friendly dollar sign, and there's going to be a friendly dollar sign. Hit it, and we're going to just double click, and bam. Equals. We want G multiply their two of their probabilities, which is this. Just for refresher, we're gonna lock this 2 since I don't want G3 this 30 to move on anywhere, and we're going to lock only the column A, but I want the row to move from 4 to 32, and same goes here. I want the rows to move from 4 to 32, but I want to lock the column G. Hit it, double click it, and that's it. Now we're going to do H, so we're going to do fast. Alright, here we go, dollar, awesome. Hit it. Voila. GHI. So now we're going to do Mr. I. Mr. I. Here we go. Multiply 5. Multiply two of their probabilities. And we're going to put dollar signs as always for the ease of our work and so that all of our figures and calculations are perfectly okay. Here. Now we're going to go with J. Multiply this, multiply this, dollar, dollar, dollar sign here, and we're going to put a dollar sign over here, hit it, double click it, J, and the last one I believe it's K. Multiply this, multiply this. I'm going to put a dollar sign as always, I'll print the dollar sign. And here we go, hit it. Alright, so now we got the covariance matrix of both of the variables, which is hourly earnings and age according to our formula. So what we're going to do is, since we have the whole table right now, we're going to sum the whole table and going to find out one single value of the whole covariance. So let's do a sum. And we want this to move from here to here. We want this to be sum equals, which is 683.905. So this is the output that I was looking for. This is the output that we need to work on right now. For this particular value, we have worked the whole covariance matrix. We have gone through so many formulas. We have done so many dollar signs that probably you guys might be like irritated by right now. So this is the number that we're going to use now for in the main formula. So now what our formula sheet says, let me see. Covariance of xy is equal to exy minus mu x multiply mu y. So we got our expected xy. This is our expected xy. Let's cover it. This is our expected xy. Let me just repeat this again. If this is our expected xy, 683.905. So let me do a covariance. Cov x comma y. Okay, let's just do this. age equal to according to a formula sheet, it's expected xy minus mu x multiply mu y. Let me see, do we have all the ingredients by right now? So we have mu y, and I believe we have mu x as well. Perfect. All are strategically placed. Okay, this, how we should read it. My mouse is working. Okay, so equal to we just only got the covariance matrix final figure, which is our expected xy. So minus, according to the formula, is mu x. Let me just double confirm it. Okay, minus mu x in brackets multiply y. So this is the covariance of AHE and H. If we want to confirm this value, we can definitely confirm it. Covariance of AHE, comma H is 6.72055, 6.72057. What I've done is I've put this number into 6 decimal places. So if I can go to format cells, I can press number. Now I can like put a 9 decimal places if you want to, just for the sake of your understanding. 6.720557325, 6.720557325, exactly the same number. Okie dokie. I hope everybody's clear with the covariance matrix and with the formulas and with the main sheet. Just to recap, guys, don't confuse yourself. It's just regular statistics that we have learned in that class, but we are doing it in an Excel environment, an Excel interface. Probably that's why it might be confusing. But if you see this video 2 or 3 times, I believe twice is perfectly. It's going to be perfect for you guys to understand what I did in this particular Excel sheet. So the final part is actually much simpler. So for the final part, what they have asked to do is to find out the correlation of AHE, which is average health earnings. I'm sorry, average hourly earnings. I'm totally messing up with average hourly earnings. And age. So I have already done this, and this was the result that came out earlier. Let's just do it again. So now, if I want to find out, okay, before going through that, let me just look at the formula sheet. Correlation of xy is cov xy, which we got it earlier, and divided by root var x, which is the standard deviation of x, multiply root var y, which is the standard deviation of var y. So now let's just find out the standard deviation of x and y. We've already got the variances. Let's just find out the standard deviation of AHE. That's going to be equal to this 0.5. It's going to be this particular value. And if I state it over here, standard def of ages equal to variance of age 0.5, that's going to be 2.7905. Let's highlight these two values because these two values will be required right now. So now if I do a correlation of HE, age, it's going to be covariance, which is this value, divided by standard deviation of AHE, multiply standard deviation of age, just put it in parentheses, voila. So that's our final value, the correlation of average hourly earnings and age. This was not an easy problem to solve, but almost took me almost like an hour to solve it. But I would suggest everybody to practice this whole problem at least twice, because it actually takes a little bit to get used to this environment of Excel with all of these covariances and all of these formulas that we have learned in the class. And it might seem pretty scary as well, but it actually not, unless and until you follow the formulas that we have learned in the class. and whatever we have covered through in the class. Just be constructive and just follow through this video. It'll help you out. Thank you very much. New Life Inside Out. Take care.